We started the recording and we're gonna continue today's class. This is the third class for electricity chapter. Last class we have seen the implication related to internal resistance, and then we've seen the potential reverse circuit application for a method called null method, by which we can measure the EMF of an unknown cell. The entire reason for this whole shebang of null method was to avoid the loss of loss voltage, to avoid the loss voltage of a certain circuit, which we saw in this case. That was that. Today we're going to start from Kirchhoff's law. This is the spelling, Kirchhoff. So it's a pretty difficult spelling. I forgot the nationality of this scientist, but I'm gonna let you hear the pronunciation of this person's name. I call this person Kirchhoff because that's easier for me to pronounce, but this is the actual pronunciation.
Kirchhoff. Kirchhoff.
Okay, that's how it's supposed to be pronounced, Kirchhoff, but
Kirchhoff.
I say Kirchhoff. So I'm gonna keep using my wrong pronunciation. But you can, if you want to correct your pronunciation, YouTube is your friend. So how do you go for the Kirchhoff's law? Kirchhoff's law actually, there are two laws for Kirchhoff's law: the first law and the second law. The first law is very simple. The idea of first law is that for any junction of an electrical circuit, total incoming current is equal to total outgoing current. That's it. Or in other terms, we can say that there is not going to be any point in an electrical circuit where you can actually store charge. If 10 coulombs is passing in every second from multiple wires, 10 coulombs per second will also be leaving from the point. So if you have a junction like this, there may be other components over here, doesn't matter. All the sum of incoming currents, here you can see that these three arrows are representing incoming currents, I1, I2, and I4, whereas I5 and I3 are leaving from this junction. So the sum of incoming currents should be equal to sum of the outgoing currents. That's basically it. We have used this idea to solve our equations from very earlier point. For example, whenever we did series combination or parallel combination, we know that this works. But who is the person who first stated this thing as a workable thing? It was Mr. Kirchhoff, scientist Kirchhoff. So it's a very simple idea. One additional thing that we remember, that this law is based upon the law of conservation of charge. Now you might wonder, what is the conservation of charge? I mean, conservation of energy, conservation of mass. These are two things that we are acquainted with. These are two things that we already know. So what is conservation of charge? The idea of conservation of charge is very simple. It simply means that by doing any physical process, we can separate equal amount of positive and negative charge out of an object, but the total amount of charge remains the same. I mean, if you have a neutral atom and if you strip one electron out of it, you're going to get a free electron of charge -1 or minus E, which is 1.6 into 10 to the minus 19 coulomb in terms of the SI unit. So you're going to get one negative charge of negative value, and you're going to have a positive ion of equal positive charge. But if you think, even if they are separated, what is the total charge there exists? That value is still 0. If you sum out these two charges, you pretty much numerically get 0 charge. And that is basically the idea of law of charge conservation, that we cannot create exclusive positive charge or exclusive negative charge. That is not going to happen. From any object, we are only capable of producing equal amount of positive and negative charges. So the first law is based upon this information. The second law says, second law is a bit interesting, and second law can prove to be a bit more complicated for certain circuits. The second law says, have a look, in any closed loop of a circuit, the word closed is very important. In any closed loop of a circuit, total voltage gained is equal to total voltage dropped. This law is based upon law of conservation of energy. If you wonder why law of conservation of energy, because you should understand that voltage is given by what? V equals to E by Q. The definition of electric potential goes like this. E equals to Vk by Q is that the amount of energy required to move unit charge from one point of a circuit to another point of a circuit is the voltage difference between those 2 points. I'll say this again. The amount of energy required, or the amount of work has to be done. Energy and work are similar quantities. So come again. The amount of energy required to move unit positive charge from one point of a circuit to another point is the potential difference between those 2 points. Now, the idea is that within a closed loop of a circuit, if you move 1.1, if you have to spend energy to move unit positive charge from one point to another point, you would be gaining that exactly equal amount of energy through the other parts where you might have those things. To make sense of this statement, we have to look at this sample circuit which we have over here. So I'll help you understand this circuit in detail. uh, I don't actually draw this part because it's already given here. So I'll help you to understand this thing from this circuit, and I'll be going slowly so that you can understand. Let me just have a look at this circuit. Here we have a large battery over here with an EMF E1. It has an internal resistance of R1. And then we have basic resistance of capital R1. And then there comes a junction B, and there is a like this, and there is another branch like this, and here comes another current flow like this. To be able to analyze the circuit using Kirchhoff's second law, we have one privilege, or we have one independence, so we have one freedom. The freedom is, if the question does not give us the arrow of the current flows, the direction of the current flows, we can assign the direction ourselves. If the question does not give us the direction of the current for each individual branch, now try to understand. If the question does not give the current flow directions for each individual branch, what do I mean by the word branch? Have a look. For this, where one single pathway of charge is one branch. So BAHG is one branch. There is a single pathway of current. BG, only BG is another branch. BC is another branch. GF is another branch. CF is another branch. CDEF is another branch. Within one branch, the current flow direction should be exactly same and exactly equal. You cannot have, let's say, 5 coulomb per second traveling through here and 6 coulomb per second traveling downwards over here. That's not going to work. And then again, if the current flow through this GH part is going upwards, that direction should remain true, or that direction should remain same for the rest of the branch as well, all the way up to the end point of the branch. This is the important bit. You have to really precisely understand that within the branch, within one single branch, from any junction to the last point, the current flow value would be exactly same and flow in the same direction. So you cannot give random arrows. So you cannot give one arrow over here and another arrow upwards, representing that two of these currents flowing in opposite direction within the same line. That would be highly wrong. So once again, first thing, if the question does not give us a specific direction of current, we have the privilege to assign the direction of those currents. Then we can go ahead and do the necessary calculation to find out the value of these currents. There are ways to calculate this. These are this equation. I'll help you to understand those. And at the end of those calculation, all the answers of this current, let's say I1, and then I2, and then I3, and then I5 through this branch, all of these current values would come with some number, and calculation can also cause them to have negative numbers. If your calculated value of the current is a positive number, it means your assumed direction was the correct direction. If the calculated value of the current out of your equation set happens to become negative, if any of the branch current turns out to be negative, this would mean that the direction that you considered is gonna be actual direction is opposite of that, but the magnitude will remain the same. So plus current means your assumed direction was true slash correct. Minus value means your assumed direction was opposite. That's the primary thing. This is one information that you have to understand. The second implication of Kirchhoff's law, second law, is that whenever we consider one closed loop, we'll exclusively bother slash deal or think or consider the resistors or components for that closed loop. For example, in this case, we can have a lot of closed loops over here. Let's say if I define the first loop, let's have a look. That loop ABGHA, ABGHA. So we're starting with a single letter and we're finishing with the same letter just to make sure this is a closed loop. I could not say ABGH. I said ABGHA, which means this defines a perfect closed loop. Whenever we are working with this closed loop, we'll simply not care what is on the what is on other parts of the circuit. This is a closed loop, means within this closed loop, Kirchhoff's second law will hold. Then we have loop BGFCB, BGFCB. So that is, whenever we are considering this loop, then we don't have to bother about what is happening on this branch. We don't have to bother what is happening on this branch. We're going to write the equation exclusively for this cycle. Then we can have loop CDEFC, CDEFC. And the fourth loop that we have over here is AHEDA, the outside loop. Multiple, we can actually have more loops over here. For example, you could also consider a loop that looks like this: ACFHA. See again, ACFHA. This is also another loop. Whenever we'll consider this loop of ACFHA, we will disregard this branch, the lower branch, and we'll also disregard the inside branch BG. We don't have to bother about them. We'll simply add the equation for the path that is just described. And interesting enough, the direction that is defined within the name of the loop is a very important factor. We have to consider the loop direction with the label current. If the current flow is the same as the loop direction, then potential drop should be positive. And if the current direction is opposite to the loop direction, then the current flow, then the potential drop would be negative. Let me show you what does this mean. Have a look at loop ABGH. I'm going to go through these loops part by part, and then for some other loop, I'm going to ask you to write the equation. So I want all of you to pay very close attention to understand this. This is absolutely new thing for you. So keep your eyes peeled. For the loop ABGHA, we're going to start from here, A. So what is happening over here, that we label this current as I1. So from GH through this battery through A and through this resistance R1, the current that is flowing through this branch was assumed to be or named to be I1. And we consider this current to flow in this direction. This arrow head represents the current flow through this direction. The loop, have a look, goes like this: ABGHA. So for this branch, is the current flow direction same as the loop or is it opposite? Current flow is happening this way and loop is happening this way. So my question that I'm asking, that for the branch GHAB, is the loop direction same as the current or opposite to the current?
Same.
Same as the current. So that would mean that all the potential drops, or I into R, current into resistance, those potential drops for this branch would be positive. So here it comes. So we're starting from here. I into R1, this is the first potential drop, plus I2 into R2, plus, because we are considering this as the loop direction, I2 was considered flowing this way. So I2 R2 also produces a positive potential drop or positive voltage. So I2 R2, we comes to G point. From G to H, there is no resistance, so there is no potential drop. From H to A, there is a resistance. What is the name of the resistance?
Internal resistance of the source.
The internal resistance of the source and it is R1. R in this case is a small one. So there here it comes. I1 R1. So once again, we start from here. I1 capital R1 plus I2 capital R2 plus I1 small r1, and we reach to the same starting point, which means all the potential drops are already written. Now we have to see whether within this loop do we have a source or not. There can be sources, there can be loops where there is no source. If the loop does not contain any source, you will simply write a zero over here. But if your considered loop does carry a source, then you have to judge that what would be the preferred direction of current produced by this source within that exclusive loop compared with that direction of the loop that we wrote. Let me elaborate. If this was only a single circuit, if this whole other stuff did not exist, how would this battery preferably produce current? Should it produce current in this orientation or this orientation? Should that current be anti-clockwise or clockwise for ABGHA loop?
Anti-clockwise.
That current should be anti-clockwise. In this case, the current should, I mean, naturally the current should be coming out of the positive end of the battery, and it should flow in this manner. So this battery will try to produce a current in the same direction as we have assumed as I1. So battery's preferred direction and our loop direction are same. Because these two things are same, that's why the EMF, or this is the voltage gain. This was the idea. It says that uh, it says that in any closed loop of a circuit, total voltage gained is equal to total voltage drop. So we first wrote the voltage drops, that should be equals to voltage gain. So if voltage gain is only possible from a source, and because the preferred direction of the source current is same as the considered loop direction, that EMF is also coming as positive. This is your equation for the ABGHA loop. এই পর্যন্ত বুঝা গেছে কিনা দেখো। Anyone, if you have any question, please respond. This is the time that I would like to answer some question if you have any. Anyone? বুঝা গেছে এই পর্যন্ত বুঝা গেছে ক্লিয়ারলি সবার? আচ্ছা, let's look at the second loop, BGFCB. BGFCB. So we are now attempting this loop in this fashion. So let's start from the first one, B. If you go from B through G, there is a resistor, and the considered current is same as the loop direction. So I2 R2 positive voltage drop. So that happens from B through G, I to R2 positive. G to F, there is no resistance, so no voltage drop. F through C, if you observe, we assume the current was happening from left to right, but the considered loop direction FC is opposite to the current direction. So we're gonna have voltage drops, but those voltage drops will be negative. So we are adding over here for this resistance is causing a voltage drop of I3 into R4. This is producing I3 into R3. But they are written in minus form because our considered loop direction was opposite to the considered current direction. So that's why voltage drops are negative. And then we comes to C point, good. And then if we observe from C to B, there is no voltage, there is no component either, so there is no voltage drop. Now this is the total voltage drop that we have. Positive voltage drops for the same direction or matching direction, negative voltage drop for the opposite direction. Now have a look for this loop. Do we have any source within this loop? BGFCB. Within this exclusive loop, do you have any source? Do you see any source?
No, sir.
We don't see any source. So the equals to 0. Let's if we have a look at for the third thing, loop CDEFC. Now, before I tell you anything, I want all of you to read this equation and check if this equation makes sense. I want you guys to try and understand this thing. Then I'm going to talk about number 4. Read this equation in this same sequence. Start from C, then go to D, and then go to E, then go to F, and then go to C again. And then consider all the voltage drops and the EMF as well. Consider this equation. See if this equation is all right or not. Take your time. দেখো ঠিক আছে এটা?
Yes, sir.
কারোর কারোর এই থার্ড লুপ নিয়ে প্রবলেম কোনো? এখানে -c2 কেন হয়েছে এটা কি বুঝছো? বলবান -c2 কেন হয়েছে?
Current direction or loop direction different.
কারেন্ট ডিরেকশন আর লুপ ডিরেকশন ডিফারেন্ট, তাই জন্য এখানে মাইনাস হয়েছে। এটা ঠিক জিনিস না। কারেন্ট ডিরেকশন উইল এফেক্ট দ্য প্লাস or minus for the potential drops on the left side. For the EMF source, you have to consider the preferred direction of current by the coil, by the battery. What would be the preferred direction of this loop? Should this loop produce a current in clockwise or in anti-clockwise? Exclusively the source.
Clockwise.
So the battery itself should try to produce a current clockwise, but the loop was considered anti-clockwise. That's why this is minus. It is, in this loop, even if this branch was aimed to give a downward current and right and upwards, even for that circuit as well, we would have to write -c2, because the battery would try to produce current in the opposite direction of CDEFC. Battery would try to produce the current in the CFEDC orientation. So the EMF plus minus sign is not dependent upon the current direction. Current direction is gonna dictate what is happening on the left side of the equation. The plus or minus of the source will come by a single judgment that would the battery exclusively on its own produce the current in our considered direction or opposite. If it is same, positive EMF. If it is opposite, negative EMF. That's the consideration. বুঝছো কি বলছি?
Yes, sir.
Yes, sir.
আচ্ছা, আর এখানে আমরা বোথ সাইডে ইকুয়েশন থেকে -1 দিয়ে মাল্টিপ্লাই করে দিয়েছি। সো আমাদের এখানে we multiply minus by -1 on both sides, we got this positive equation. Now interesting enough, what I want you kids to understand that this was the equation written for, this equation was written for CDEFC. If you just reverse this order of observation of this same loop CDEFC, if this loop is observed by CFEDC, you would get exactly this equation. Check it out. Now try to go through CFEDC. See if you get this equation. Let's go part by part. CFEDC. বুঝাচ্ছে?
Yes, sir.
So এই কথাটা আমি তোমাদেরকে এই জন্য বললাম, the reason I'm telling you this is that to signify that once we choose to analyze a certain loop, in which orientation are we judging that loop does not at all affect the equation of that loop. Whether you consider the loop in clockwise direction or you consider the loop in the anti-clockwise direction, you would end up with the exact same equation for the same loop, unless you make a mistake. If you consider in one direction, simply multiplying by -1 on both sides reverses the considered loop direction, which works. Okay, let's now have a look at the biggest loop over here, biggest in terms of size for the circuit. So if we go for the loop AHEDA, once again try to understand this on your own and see if it makes sense. AHEDA.
কারেন্ট ডিরেকশন সেম ধরতে হবে না পুরা লুপের জন্য?
নো, একটা ব্রাঞ্চের মধ্যে কারেন্ট ডিরেকশন সব জায়গায় সেম হতে হবে, বাট পুরো লুপের মধ্যে ডিফারেন্ট জায়গায় কারেন্ট ডিরেকশন ডিফারেন্ট থাকতে পারে। কোশ্চেন এনিওয়ান?
তাহলে আমরা GHAB আর CDEF আলাদা ব্রাঞ্চ ধরতে পারবো?
দাঁড়াও,
GHAB আর CDEF।
GHAB আর CDEF, হ্যাঁ, we can. Well, we do not say CDEF, we say CDFC. We always end up with the same letter to make sure this is a closed loop. We did ABGH right over here. We did CDFC right over here. So yes, the answer to your question is yes. Do you guys properly understand why this is E2 minus E1, why E2 is positive and E1 is negative? এটা কি বুঝছো? খুব ভালো করে খেয়াল করো।
জি স্যার।
This considered direction of AHEDA. We have to consider the two involved batteries within this loop individually. This is the convenient direction for E2 battery, but this is a inconvenient direction or reverse direction for the E1 battery. So depending upon our loop consideration, the E2 will be a positive EMF because the current produced by E2 is supposed to be in the same direction, and E1 is written as the negative EMF. So this is a important bit. Now, if we want to go for any other part of the circuit or any other loop, we can definitely go this. For example, let's say if I want to write the equation for ACFHA, what should that circuit look like? Hear me out again. ACFHA. If I want to write that one.
Sir, can you repeat it, please?
I will. Just a second. If you consider a loop that is this A, C, F, H, A. So for this loop, what should be the equation? Tell me. We'll start observing from A. From A to B, is there any resistance? Yes.
R1.
R1. So we're going to write positive I1, R1.
Yes, sir.
Then from B to C, do we have anything? No. Forget
No,
about
sir.
it. From C to F, we have two
No,
resistors
sir.
with a single current. Beautiful. So I3 into আমার তো লেখা সব আসমানে চলে যেতেছে। This is also another style of writing. You can adopt this as well. You might wonder that, well, we have named those currents by their register names. So why is there no I4? Why is I4 in the circuit? We have I1, I2, I3, and then I5. Where is I4? Why don't we have I4?
I4 আর I3 equal current same branch.
Exactly, because they're in a series combination, I3 and I4 would be same. So there is no point naming the same current of a single branch with two different names. This will simply increase number of variables and ambiguity in the circuit. So that's why we did not do a different naming. So I think I4, and then we go from F to G, nothing is here. G to H, nothing is here. How about from H to A? That is gonna give us I1 into R1. This is the total voltage drop for the ACFHA loop. This should be equals to E1, because E1, this constant direction is the convenient direction for the E1 battery to produce a currents on its own. এই সার্কিটটা দেখো, এই কোশ্চেন লেখার সময় কিন্তু আমরা ভেতরের বিজি সার্কিটটা এর ব্রাঞ্চটাকে জাজি করি নাই, এবং এটা জাজ করা লাগবে না। উই হ্যাভ টু সিম্পলি বদার, or we have to simply consider the exclusive part of the branch of the loop which are mentioned. Otherwise it's not needed. Make sense?
Yes, sir.
Okay. So এই হচ্ছে কার্শফস ল এর বেসিক কাবজাব। আমরা যদি এইটুকু পর্যন্ত ইকুয়েশন বিল্ডআপ প্রপারলি বুঝি, if we understand this part well, then practically solving the Kirchhoff's law problems would be actually very, very easy. You have these set of writings over here. I actually talked about this part as I was explaining this thing, but I want all of you to read this thing. You have your own notes, you can read from there, or if you want, you can also read from the PDF that I'm showing you. Doesn't matter. Take some time, 2-3 minutes, and read these things slowly and carefully, and ask me any questions if you have. পড়ে দেখো, কোন কোশ্চেন থাকলে আমাকে জিজ্ঞেস করো। বুঝা যাচ্ছে কি এই কথাগুলা?
Yes, sir.
জি স্যার।
Same stuff as I was saying, just written in words, so that if you forget, you can get back here and have a revision and remember what I said. That's basically it, the end of our electricity chapter, in terms of theory, of course. So now I'm gonna start helping you with some problem solving, because there is another thing, that the voltage drop calculation that I did not discuss in this theoretical part, but that because that's the part exclusive MCQ problem. So yeah, I'm gonna pull out the worksheet and try to see to find out some interesting questions that want I want to help you people.
Sir,
Bolo.
স্যার চ্যাপ্টার 11 বইয়ের ওইটা কি আমাদেরকে করানো হয়েছে? রেজিস্ট্যান্স এন্ড রেজিস্টিভিটি।
Yeah, well, I am teaching you current electricity, so resistance and resistivity আমাদেরকে করানো হয় নাই। আচ্ছা, resistance resistivity actually আমাদের এই নোটটাতে থাকার দরকার ছিল। There is a reason this was not included, because this is actually very simple stuff. I can show you right now. Resistance resistivity idea is very simple. The idea is, if everything else is the same, resistance of a conductor is directly proportional to its length. If everything else is same, resistance of a conductor is inversely proportional of its cross-sectional area. And then if we combine these two proportionalities, we're going to get R proportional to L by A. If we want to make this proportionality in an equation, obviously for the sake of requirement, we're going to get R equals to rho L by A. So this rho is what we call the resistivity, and this is a new term that is brought to your knowledge, I believe. So if you wonder that why are you using the symbol rho, doesn't that mean density? Well, the scientists or the people who actually first came up with this expression of dependency, the resistances having dependency on thickness of wire or length of wire, they wanted to label this as rho, and we're still doing this. So this is basically a historical choice which we did not want to change. Interestingly, you have to understand, whenever the question shows up, that is this the part of this question, is it relevant to the optical stuff, or is it relevant to the actual weight stuff? and based upon that we're going to help you further. So এটাই হচ্ছে আমাদের রেজিস্টিভ ইকুয়েশন। এই ইকুয়েশনকে অনেকভাবে ইউজ করা যায়, বাট লেখার সবচেয়ে গেল হ্যাঁ দেখছি, বাট লেখার সবচেয়ে মানে ভালো বুদ্ধি হচ্ছে হ্যালো।
Yes, sir.
So এটা বুঝছো সবাই, এই equation is very simple, it's a very small thing, that's why I didn't go for this. But depending upon this equation we have to solve a lot of proportionality math, which I'm going to show you whenever we'll pick up the MCQ paper, so no big deal. So I
Sir,
was trying to
আরেকটা question ছিল।
বলো।
Sir, practical circuits কোনটা?
Practical circuits means regular life circuits which are made with regular equipments. For example, a circuit that has a battery with internal resistance, ammeter that has some negligibly small resistance, voltmeters which doesn't have infinite resistance, rather it has a pretty large or quite large resistance. These are the types, I mean, which we consider to be practical circuit.
আচ্ছা স্যার।
Number 3, give it a try. বুঝা গেছে? এটা কারেন্ট আনসার কি হবে?
C.
C happens to be correct. Can you say why? You have to see that these two connection points are basically a point where the incoming current is going to split into two parts and flow through the series combination of PQ and RS. What are we doing over here? We're bringing the cell at the middle. Here comes goes current out, and you see there are two things, P and Q. The same thing was available here as well. And then this current flows through this pathway and eventually through R, it reaches up over here, which, in my opinion, also makes sense because they are similar words, but there is this very slight important bit that you really need to consider, that electrically these two circuits are practically identical. Electrically, these two circuits are practically identical. Yeah. এটার পর আমরা ট্রাই করি হচ্ছে লেটস সে this one, number 9. Read the question, attempt, then check. You can check your answer with the answer key. If you're okay, move on. If you have any question, you ask me.
3টা আবার বুঝাই দিবেন।
কোনটা 3?
জি।
You need to see that on the left circuit, current is coming out of the battery. It is coming to the first junction, and then the current is getting divided into two branches. I'm not gonna say it is. I mean, the current is divided and flows through two bulbs at the same time. So on the left diagram we have PQ, and on the right diagram we have PQ as we have. Sorry, on the left diagram the current divides into these two parts. So the same current flows to PQ, and here the same current flows to RS. Same thing is going to happen over here as well. Current is going to come out, and then what? Pull on ball.
Going to divide.
As the current will reach to this point, it will split because there are two pathways to go through. So on the left side, as the current splits on the top branch, it flows through P and Q voltage, and within the RS part, it measures the RS voltage. Now, because the current is getting divided through the P end and also the R end, so these two currents will remain ideal, or these two currents will become these two currents that is getting, I mean, after the splitting is being done, these two currents will ultimately merge with each other at the end of the complicated circuits. So whenever we are getting a situation like diagram 2, so we have to understand that current is going to rise from the positive end of the thing. Current is going to happen inside. So electrically these two circuits are perfectly identical. They are just two different ways to draw this figure. বুঝতে পারছি?
Yes, sir.
Yes, sir.
আচ্ছা, so I was now trying to get at this problem. কত আমরা বলছিলাম এখানে?
9 number, sir.
Nine.
হ্যাঁ, 9 নম্বর। সো 9 নম্বরটা কি হবে?
স্যার এ হবে মনে হয়।
এ হবে।
স্যার আমারও A আসছে।
Okay. So I think A is the correct response, right? মাসিম দেখো তো কেউ একজন।
Yes, sir.
আচ্ছা, so এটা গেল একটা জিনিস। Number 10 is actually pretty simple, but there is a word type of trick that the CA people have played. Have a look at question number 10. I'm reading the question. A copper wire of cross-sectional area 2.0 millimeter square. Sorry, কত নম্বর বলছিলাম? Number
10.
10. A copper wire of cross-sectional area of 2.0 millimeter square carries a current of 10 ampere. How many electrons pass through a given cross-section of the wire in 1 second? So try to understand the significance of the question, then I'm going to leave. So the thing, the wire is carrying a current of 10 ampere. So every second 10 coulomb charge flows through. All that you need to find out how many electrons, you know the elementary charge, make up 10 coulomb. So how do you do that? 10 divided by number of charge of one charge particle, one charge particle. So that leads us to the decision that current value should be, did you could say 6?
Sir, did you ask us anything?
Hey, what I was trying to say that if you can find out exactly how many electrons make up 10 coulomb, that's basically your answer. Because every single second we are transferring this much কত ampere জন লিখছে এখানে to 10 ampere worth of charge. So 10 coulomb per second. So you just need to find out how many electrons would be required to achieve 10 coulomb, and that's it. So simply 10 divided by the charge, elementary charge of an electron, and that would work beautifully. আচ্ছা আমি একটু নাম্বার 11টা দেখাই। নাম্বার 11 is about one of those last thing that I showed about the fraction or ratio thing. Let's have a look at this question. Have a look. A cylindrical piece of a soft electrically conducting material has resistance R. It is rolled out so that its length is doubled and but its volume stays constant. So this is important information. If the volume stays constant, obviously this would mean the cross-sectional area has become half. Because if I mean you have to understand this thing, okay, that volume is given by cross-sectional area into length. If volume is constant, now the question says that it is rolled out so this length is doubled. So whenever the length has to become double, if it increases by a factor of 2, this one has to also reduce by a factor of 2. এটা কি বুঝতেছো?
Yes, sir.
আচ্ছা, so এখানে বলছে হচ্ছে what is the new resistance, and so now to consider the new resistance there are many different ways we can go for. I am showing you a way that I personally feel comfortable with, that is R is proportional to length, which means when length has been doubled R would become 2R. দেখো আমি এটা আমার সুবিধার জন্য লিখতেছি। Second thing হচ্ছে because it was rolled out and the cross section area become half, R is also proportional to 1 upon A. Here A was converted into A by 2, which should be leading to what? Resistance should become what? More or less? When the cross section area become less, what happens to the
More.
resistance? Resistance become more. So now the R should become 2R. That's basically it. So you can see that the length change factor will cause a doubling of the resistance. The cross-sectional area factor will also cause another double area factor. So if you just do multiply these two numbers, so the total change of R should be 40 এরকম কিছু একটা। সো এটা হচ্ছে আমাদের এই রেশিও বেস করে ক্যালকুলেশন করার সিস্টেম। এই সিস্টেমটা বুঝে গেছে কিনা সবার?
Yes, sir.
কার কোনো কোশ্চেন থাকলে বলো। It's important that you understand this thing properly. There is another way that by which you can actually write up two set of equations and then divide them. Similar quantities get cancelled out and so on and so forth. Blah blah blah. That I personally find that method to be quite intimidating or like weird or just unnecessarily complicated. But there are certain questions where it can really help. Where in those cases I'll help you. So এটা গেল। How about we give it a try for number 13?
স্যার আমরা তো আপনার দাগাদাগি ছাড়া কিছুই দেখতে পাচ্ছি না।
Because I asked you to look at your worksheet and try to figure out this MCQ.
ও স্যার একটা ডিভাইস তো এই জন্য সরি।
নো প্রবলেম, নো প্রবলেম, নো প্রবলেম। তোমাদের বুকলেটটা বের করো, 13টা দেখো। Try to understand. You are allowed to be mistaken. This is a basic class. So, but be bold about your decision.
Sir, is
D.
the answer B?
Okay. Here the source is V. The drains are V2 and V3. V2 and V3 are the voltage across R and 2R. But it just so happens these two resistors R and 2R are in parallel, right? Parallel combination across the voltage same হয় না?
Yes, sir.
Which means you are sure
Yes,
V2 equals to V3. এখানে কোনো confusion নাই. What will be the total voltage drop across these 2 points? Let me copy this. What will be the total voltage drop between these 2 points? Is it going to be V2 or is it going to be V3 or is it going to be V2 plus V3?
V2 or V3.
It will be V2 or V3. Beautiful. You cannot say it will be V2 plus V3 because they are not in series. Only in series combination do you have ever the sum of the voltages. Here they are in parallel. It cannot be V2 plus V3. It should be V2 or V3, which leaves us to the equation that the appropriate equation of voltage drop for this equation by Kirchhoff's law should be either you can either write V equals to V1 plus V2, or you could write V equals to V1 plus V3. Or the third equation that could be appropriate is V2 equals to V3. These are the only three equations which are true for this circuit. See if it makes sense. Now you have to figure out which of these following options is all right. Once again, have a look at the 4 options and see if you can choose the correct one. Give it a try. কোনটা হবে correct answer?
D.
B কেন হবে না? সরি, A কেন হবে না? এটা সবাই বুঝছো?
Ji, sir.
স্যার আমাদেরকে কি প্র্যাকটিক্যাল সার্কিটের চ্যাপ্টারটা করানো হয়েছিল?
তোমাদের বইতে কি প্র্যাকটিক্যাল সার্কিট নামে নতুন ডিফারেন্ট চ্যাপ্টার আছে?
sir.
G, sir.
চ্যাপ্টার 12 বলা 12 লেখা।
আচ্ছা, আমি দেখবো একটু পর, সমস্যা নেই, ডোন্ট ওয়ারি। আপাতত একটু এইটা সেটা দেখে নেই, আমি রাতে দেখে রাখবো, তোমাদের সাথে কালকে এটা নিয়ে আলাপ করবো, সমস্যা নেই।
আচ্ছা স্যার।
এখন বই ঘাটতে যাচ্ছি না, এই জন্য আর কি। 21টা ট্রাই করো তো। 21 21 কাজ শেষ করে সাথে সাথে ঘুমাই যাবো, ঠিক তো পারতেছি না। প্রচন্ড টায়ার্ড লাগতেছে। আমার নতুন বাসার সামনে রাস্তায় একটা আমেরিকান শর্ট ইয়ার স্ট্রে ক্যাট আছে, বিরাট।
স্যার বাসায় নিয়ে আসেন।
এটা ধরা যায় না, মানে ছেলে
Sir,
বিড়াল
cover them.
খাবার দিলে ডেফিনেটলি ধরতে দিবে, বাট I have never seen an American short ear in person. They are quite rare within this region, but this is an American short ear cat which is stray. Like I was like, what?
স্যার মেবি
Kick
কারোর
out
পেট
করে
ছিল।
দিয়েছে, sir.
Yeah.
There is a possibility, and if either that is a possibility যে কেউ পালতো and বাইক করে দিয়েছে ভারত থেকে, পালা বন্ধ করে দিয়েছে, or কেউ পালতো সেই বিড়াল বাইরে এসে তার বাচ্চা কাচ্চা পয়দা করছে, and this is one of those kittens which eventually lived long enough to become a full grown male.
That is a possibility.
Sir, মুটির কি অবস্থা?
মোটি ভালো আছে, মোটি সুখে শান্তি সন্ধে তার বংশ বিস্তার করে যাচ্ছে।
আর আরেকটা বিড়াল যে হয়েছিল with eyes with two colors, I guess.
সুন্দরীও একই কাজ করতেছে, সুখে শান্তিতে তাদের বংশ বিস্তার করে যাচ্ছে।
আপনি এতগুলো বিড়াল নিয়ে এখন কি করবেন, স্যার?
ওরা সবাই আগের কোচিং আছে, মাঝে মাঝে গিয়ে দেখে আসি। আর ওই ওখানে যে দোকান আছে, দোকানে একজনের কাছে খাবার কিনে দিয়ে আসছি, হি টেকস কেয়ার অফ দেম। আমি খালি নাম বলতেছি, American short hair না। I was talking about this breed. What is this breed? This breed. This kind of cat, ear. Curl cat. এই curl cat এর নাম কি? Scottish fold, right? This one. This ear curl is really rare. Josna?
Yes, sir. স্যার আপনি এটাকে অ্যাডপ্ট করে নেন, তাহলে আপনার ওর অফস্প্রিংস গুলো আপনি পেয়ে যাবেন।
চোখগুলো অনেক সুন্দর।
এটা আমি যেটা দেখছি ওটা চোখগুলো এত সুন্দর না, because I believe this is a cross between a actual brand and then some from here. I think so, but they have really their eyes are really close to each other, and compared to their head size, মানে the gap between the eyes is very small. I mean,
স্যার কি বলেন, বাংলাদেশে বিড়াল there was like this stray cat, ওটাকে আমি সবসময় খাবার দিতাম, তো আমার কাছে আসতো সারাদিন। ওইটারও তো লাইক একটা মিন্টিশ কালারের চোখ ছিল, they were really beautiful.
বিলাই অনেক সুন্দর। আচ্ছা যাও, বিলাই বাদ। এমসিকিউ কোনটা 21 এ কার্ড আছে কি হবে?
ডি।
মিলছে? মানে আনসার কি সাথে মিলছে?
চেক করে দেখি।
চেক করে
জি
দেখো।
স্যার।
26. $26.
A.
A happens to be the correct response. B happens to be the description for terminal voltage. এই জিনিসগুলো তো আমাদের এসকিউ লিখে রাখো। মানে হচ্ছে if option if I slightly change the B option, this would be true. For example, I could say the terminal voltage of a cell is the energy transferred by the cell in driving unit charge through the external resistance. That is essentially what we call terminal voltage. C happens to be the definition of loss voltage. The loss voltage of a cell is the energy transferred by the cell in driving unit charge through the internal resistance of the cell. সো এই দুইটা এক্সট্রা ডেফিনিশনের টার্মগুলা পাশে লিখে রাখো, তাহলে পরে যখন উল্টাবা ডেফিনিশনগুলো চোখে পড়বে, একই টাইপের ওয়ার্ডিং, জাস্ট একটু চেঞ্জ করলেই পুরো ডেফিনিশনের সোর্স চেঞ্জ হয়ে যাচ্ছে। সো ইটস ইজিয়ার টু রিমেম্বার দ্যাট ওয়ে।
আসলে তো ইএমএফ ফোর্সের সাথে কোনো রিলেশন নাই, তাই না?
না 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 না, ইটস জাস্ট আ টার্ম দ্যাট সামওয়ান মেসড আপ এন্ড উই আর স্টিল মেসিং আপ দোজ থিংস। থার্টি ওয়ানটা স্টার মার্ক করো। আজকে ইফাত ক্লাস করতেছে না, এই যে আমার শরীর খারাপ হতে পারে। সমস্যা নেই, আমি লেকচার আপ করে দিব সেখানে। থার্টি ওয়ান পারতেছো?
করছি।
আচ্ছা, ট্রাই করো, সমস্যা নেই। What the? Oh. $16,000 একটা ক্যাটের দাম, স্কটিশ ফোল্ডের দাম। হট ড্যাম। Oh, imported from USA. এই বিড়ালটা আমার ধরা লাগবে, স্কটিশ ফোল্ডের বিড়ালটা, এটা সামহাও আমার এত করা লাগবে। তুমি দেখলে তাহলে কত আসে আনসার?
স্যার করে দেন।
Let's have a look. The question says the battery supplies a total power of 12 watt. What is the potential by hitting the resistor R? So what is the power over here? This is a difficult question because it's apparently it's difficult to operate. Question says that the resistance have equal resistance. The resistors PQ are equal resistance. This is a helpful information. So let me just draw the current over here. If this part carries a current of I, these two parts should be carrying a current of I by 2 and I by 2. Do you agree on this?
দেখছি স্যার একটা সেকেন্ড।
Yes, sir.
Now, you might wonder why on earth, out of every single variable that this I could have written over here, am I choosing to write the current value? The idea is very simple. Power is given by I square R, and in this case, this is easier for me to work with. If you wonder why not voltage, voltage দিয়েও করা যাবে, voltage দিয়ে করলে আমার সেভেন সেভেন, voltage দিয়ে একটু করে দেখাবো, but I personally am very comfortable with the current calculation. So I'm going to show you this first, and then maybe for interest, I'll show you the voltage calculation. So P is equals to I square R. So we're going to use this number to go for our calculation. So have a look. The power of P, so power of P should be equals to I square R. I'm considering the resistance of each resistor as R. The power of Q should be I by 2, sorry, I by 2 whole square R. also the power of r should be also I by 2 whole square into r. I'm assuming that you could use any other number over here, maybe x, y, z, or anything else, so that you do not confuse r and r. But I'm okay with this, no big deal. According to the question, the sum of all of these variables, I square r plus, so no, sorry, I'm not going to do this sum. If I do the ratio of these three terms, how much am I going to get? I square r is to I by 2 whole square r is to I by 2 whole square by r. What you're gonna get? You're gonna get I square r into 1/4 is to 1/4 of I square r is to 1/4 of I square. এই পর্যন্ত বুঝছো কিনা দেখো। আমি যদি পাওয়ার তিনটা রেশিও করি, I'm gonna get this ratio. Is it clear up till now?
Yes, sir.
Yes, sir.
এখান থেকে আমি I square r গুলো সব কাটে দিলাম আর পুরোটাকে 4 দিয়ে মাল্টিপ্লাই করে দিলাম, which I can because it's a ratio. So I'm gonna get 4 is to 1 is to 1. এই জিনিসটা আমি বের করতে যাচ্ছিলাম। Yeah, what would be the ratio of power between P of P is to P of Q is to P of R? This ratio is supposed to be 4 is to 1 is to 1. Once I know this information, rest of the part is very simple. You just have to divide 12 in this ratio and find out how much this have. So this part is going to be the power of the R. This is going to be 1 divided by 6. 6 comes from the sum of all the ratio components multiplied by 12. Gives you 2 watt. That's the answer. বুঝা যাচ্ছে?
Yes, sir.
Yes,
Yeah.
sir.
ঠিক আছে, এটা একটা দরকারি ইকুয়েশন। আচ্ছা, আমি একটু বলছিলাম যে আমি এটাকে ভোল্টেজ দিয়ে করে দেখাবো, জাস্ট তোমাদেরকে বোঝানোর জন্য আমি এটাকে ভোল্টেজ দিয়ে করে দেখাচ্ছি। I personally don't like working with voltage very much, but still I am willing to show this problem because this problem is unique. Let's assume the voltage across this P resistor is V. Let's say this is consuming a voltage of V. What would be the voltage across this parallel combination? Do you understand this part?
Yes, sir.
এটা কেন
Yes.
হবে? Why should this happen?
Sir.
হ্যাঁ বলো।
Sir, split.
Q আর R এর কম্বাইন্ড রেজিস্ট্যান্স P এর রেজিস্ট্যান্স হচ্ছে হাফ, তাই জন্য ভোল্টেজ এর শেয়ার হাফ পাবে।
Zarif is absolutely correct. That is exactly what I was gonna say. If you observe this thing in terms of combination, here we have a series circuit where one of the components of the series circuit is a parallel combination. So here you have one component and here you have one whole component. So voltage will be shared over here. So because this component has double the resistance compared to this combination, so this will definitely eat up double the voltage compared to the individual voltage of both of these persons. Make sense? If you understand this much, then the rest of the problem is also very simple. That's I'm gonna try to figure out PP by PQ is to PR. So what I'm gonna write, this is gonna be V squared divided by R is to V by 2 whole square divided by R is to V by 2 divided by whole square into R. So this is going to be the ratio for these two things. So if I keep on attending this, P square by R is to, never mind. এখানে আমি আর গুলাকে অলরেডি বাদ দিয়ে দিই, শুধু গার্বেজ করে ক্যারি করা তো মানে নাই, আর গুলি সব বাদ। এটা কত আসলে এটা? হ্যাঁ, কি হলো? হ্যাঁ। So here the ratio is gonna be, let's get rid of the r's. So we're gonna get v square is to v square by 4 is to v square by 4. And by all sides by 4, we're gonna get 4 is to 1 is to uh, is to 1 is to 1. So once we get this ratio, once again, the rest of the math is very simple. That we are gonna have to divide the number 12 in 4 to 1 to 1 ratio, and that pretty much does it. এভাবে করতে পারো if you want. দেখো দুটো মেথড বুঝা গেছে কিনা,
Yes, sir.
ঠিক আছে? আচ্ছা, আমাদের ক্লাস কি আজকে এটা 11টা বন্ধ ছিল নাকি 11:15 বন্ধ?
11টা পর্যন্ত,
11
স্যার।
আচ্ছা ঠিক আছে, I'm gonna close the class today because I'm actually pretty tired. আমি 5:30 থেকে একটা ক্লাস নিচ্ছি। আচ্ছা 3টা ক্লাস ছিল আমার, which is weird. Today is Friday. Anyway, সো শুনো, তোমাদের লেকচারটা আমি আপ করে দিয়েছি, তোমার সাথে কালকে আমাদের ক্লাস আছে, কালকে আমরা আরো ফার্দার কিছু করবো। তোমরা যদি এমসিকিউ পেপারটা অ্যাটেন্ড করতে চাও, যদি পারো, সময় পাও, তাহলে এমসিকিউ পেপারটা একটু অ্যাটেন্ড করে রাখো। I'll pick up these questions of your problems in our next class. ঠিক আছে, আজকে একটু থাক, বাই।
আসসালামু আলাইকুম, স্যার।
বাই
হ্যাভ এ
স্যার,
গুড নাইট।
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম, আল্লাহ হাফেজ।